All right, so these are the exercises that you've got for 9.2. This should be already in your possession. So what we're going to do for these is a little bit more practice on running hypothesis tests. So the directions are going to say for each of these, go through the full thing. So null and alternative hypotheses, find the p-value. Probably it's a good idea to mention our test statistic as well, state whether we reject or fail to reject the null, and then say, hey, what does this mean in terms of the context of this actual problem? So for the first part here, we've got an automotive battery manufacturer guarantees the mean reserve capacity of a certain battery is greater than 1.5 hours. Okay, so we see a couple things, right? It's a mean, so definitely we're going to be talking about hypotheses involving mu. So the null and alternative, right, which is either H1 or HA, whatever you would like. These are going to involve mu. And the null always says mu equals something. The alternative is going to be, what are we trying to show that's something other than equals? So greater than, less than, or not equal to. This says greater than. So we're going to try to show that it's greater than 1.5 hours. So the null is that it is exactly 1.5 hours. Okay, to test this claim, we randomly select 50 batteries. Okay, that's going to be a piece of information for us there. That's n equals 50. Find our mean reserve capacity. So from the sample, the mean was 1.55. So x bar was 1.55. And the population standard deviation. So in this one, we know sigma. So if I know sigma, if I know the population standard deviation, what this means, this is going to tell me to use z. So this is going to be a normal curve, right? Use z for our test statistic. At alpha equals 0.10. So usually we say that after our null and alternative hypotheses, we state what's going on here. So remember, this is equivalent to saying a 10% confidence, 10% significance level. We want to see if we have enough evidence to support their claim. They're believing, okay, this is greater than 1.5 hours. So we're going to run through this. Of course, we can do this by hand, right? We can find the test statistic by hand. We can use normal CDF since this is a Z test statistic, the normal curve. But we also know we can go to stat. We can go over to tests, and we can say, hey, I want to run a Z test, right? I know I want to run a Z test and not this other stuff because, first of all, the other stuff down here is intervals. These other things we haven't really talked about. So 2 samples or 1 prop, we're going to do that in 9.3. But yeah, we're running a Z test. So let's hit enter there. Do we have data or stats, right? Well, data would be if we had stuff in a list. We do not. So we actually have the stats. So we're going to say, all right, our mu value is 1.5. Our sigma, and this is reminding you, hey, if you're using a z-test, you better know sigma. It's 0.32. X bar is 1.55. N is 50. And then this is saying, hey, what do you want your alternate to be? So is it not equal to, less than, or greater than? In our case, it is greater than. So hit enter. Remember, we have the 2 options, calculate or draw. If you want to see what this looks like, visualize it. You know, is it one-tailed or two-tailed? If it's one-tailed, is it left or right? That kind of thing. We should know because we're using greater than. This is a right tail, right? One tail, but it's to the right. So I'm just going to calculate here. And we come up with, right, a couple of things. Our test statistic, right? So our test statistic is Z, test stat, Z, and sometimes this is something that we want to be able to reference. So 1.105 if we're rounding to 3 decimal places, and I'm just kind of choosing that arbitrarily. But the most important thing is the p-value. Right, the p-value is just given by p here, so it's 0.1346. This is what we compare to alpha. Right, these 2 guys we're going to compare. So we see that P is greater than alpha. What does that mean? Let's remind ourselves, because p-values, this is one of the most complicated ideas, I think, for most people to wrap their head around. So what does this mean? We have assumed the null is true. So we assume this guy to be true. And we say, okay, given that assumption, we went and took a sample, we got a sample mean, 1.55. What's the probability that we get this type of sample result, 1.55, if the null really is true, right? Basically, we're saying, how likely is it to get this type of sample, assuming the null is true? Well, this says we get that type of sample, right, about 13.46% of the time. Well, 13.46, maybe that doesn't sound like a whole lot, but we compare it to our alpha level, right? So we want to say, what's the likelihood of getting this result, assuming that the null is true? If your p-value is really small, that's when we say, hey, something's kind of suspicious, something's fishy here, right? But in this case, our p-value is not very small. It's certainly not smaller than the alpha level. So because of this, p is greater than alpha, we say we fail to reject the null hypothesis. There is not enough evidence to suggest that the null is untrue. Now, again, we don't embrace it. We don't say we accept the null. We just say we fail to reject it. So when we're trying to make a conclusion in basically in the context of this problem, we say at the 0.10 level or confidence level, and maybe I'll throw confidence in there just to be clear, at the 0.10 confidence level, or the alpha equals 0.10, or the 10% confidence level, you can kind of play with that a little bit. At the 0.10 confidence level, there is not enough evidence to reject the null hypothesis. That the mean, and what are we looking at? The mean reserve capacity is 1.5 hours. Therefore, we do not have evidence, ooh, my spelling tonight, to support the manufacturer their claim, right? Because their claim was that the mean is greater than 1.5 hours. So if we rejected the null hypothesis, we would have said, hey, now we're looking at the alternative, and that is what they're claiming. They're claiming it's greater than 1.5, but our sample results do not say that there's enough evidence to do that. Okay, so there's that idea. I'm just going to put that in bold to kind of separate it from this next problem. Okay, so this one, the drug 6MP is used to treat leukemia. The following data represents remission times in weeks for a random sample of 21 patients using 6MP. Okay, we know that probably when we're given data like this, we're going to need to go to stat and then edit and put all this data in list one. Now, I already did that, so, and I already actually see, again, this thing's kind of glitchy, but I saw an error in there, which is good. I'm glad I caught that. So put all of your data in here. You can pause the video, put it in. It would be a very wise idea to do this along with me and also make sure that there's not any other mistakes in this list so that our answers are the same. So pause and do that and then come back. We are going to assume the X distribution is mound-shaped and symmetric. That sounds kind of like a normal curve. But we also have, 21 patients. Well, we go, okay, that's not a sample size of 30. That's unfortunate. But we are able to use, we're not given a sigma value. So it sounds like we're going to use the sample standard deviation, S. So because of that, we're probably going to look at a t-test, right? T-test if we don't have sigma, right? Sigma is unknown. Okay, so a previously used drug treatment had a mean remission time of mu equals 12.5. So remember, this is like our historical value that we would go off of. So for the null, we're going to assume that history is repeating itself, 12.5, and we'll see what we want for our alternative. Again, we're using mu. Again, we're using 12.5, so it's just greater than, less than, or not equal to. Do the data indicate that the mean remission time is different either way, right? Different either way just means not equal to. We're going to use alpha equals 0.01. So we want to be really, really sure. We want our results, if the sample comes back and it's really, really unlikely, given that we assume the null is true, then we'll reject it, right? So we're going to assume the null is true. and we're going to see if that holds up. So we have all of our data. We're going to go to stat, over to tests. We said, hey, we're using a t-test because I do not know sigma. So then we say, well, actually, I put all the data in, and it's in list 1. Now, the only thing I have to do is update my mu 12.5. It's already referencing list 1 by default, but if you need to change that, go ahead. The alternate hypothesis, we want to make sure to change this to not equals, right? And then we're going to calculate. Okay, so what do we want to take away from this? Well, there's a few things, right? For starters, we probably want our test statistic. So our test stat this time is not Z, but it is T. So this is 2.106 if we're rounding to 3 decimal places. And usually I go to 3 just because it tends to be enough. Our p-value is going to be 0.048, which is pretty small. So these sample results are pretty unlikely, right? And again, just to be clear, our sample result was that X bar for this particular sample was 17.095, right? That is definitely much larger than 12.5. However, we want to be absolutely certain. We want to be super, super certain, right? We're never absolutely certain, but 1% is very small. It's hard. It is going to be hard to reject the null if your alpha is this small. And in fact, right, we see this again, that p is unfortunately for us greater than alpha. I mean, not unfortunately, just means that we fail to reject the null. And so what does that mean in context of this problem, right? So we just say, well, in the context of this problem, so at the 0.01 confidence, oops, sorry, keep doing that, not confidence, significance level. Did I do that above? Let's check. Oh, I did. Not confidence, come on now. Significance level. Confidence level, of course, is for our confidence intervals. And now those are related to tests. We're actually going to get into that later, but we're talking about significance here. So at the 0.01 significance level, there is not enough evidence to suggest, right? What does it mean if we fail to reject the null hypothesis? It means we do not have evidence for the alternative. So there is not enough evidence to suggest that the mean remission time is different from the historical value of 12.5 weeks. You'll get more practice with these as you're working through the homework because some of them are going to be set up for you. But keep in mind on tests, you are going to have to be able to state these things for yourself. And there's a lot of ways to state them, right? The way I said this one is not exactly what I said above. So you just need to include, right, the significance level and then whether or not we are rejecting the null and basically just what that means, right? Do we have evidence for the alternate or not? Okay, I hope that's helpful. In 9.3, you're going to take a look at proportions and basically do the same thing, run some tests on proportions.